Okay, gurus, Kubernetes primer. So I think at a really high level, Kubernetes is an open source platform for running cloud native apps. But let me break that down. You start out with bare metal or some infrastructure on a cloud platform, and don't switch off at the mention of infrastructure if you're a developer, stick with me. So you've got this bare metal or some cloud infra, and you need something on top of it to run your apps on. Well, that's Kubernetes. It's this layer that's sitting above the VMs and the likes, and it provides a rich API and an extensive set of primitives for running cloud-native apps. But what the chuff is a cloud-native app? Well, keeping it simple, at their core, cloud-native apps are built from lots of small interacting services that come together to form something useful, a useful app, yeah? And this building them from small simple components makes them really easy to scale and update, and even do things like canaries and blue-greens. So the opposite of the old monolithic apps, if that helps. Like, monoliths were kind of big honking binaries, and they were a nightmare to scale or do updates on. So cloud-native apps are a collection of small, specialized components, usually containers, that come together to form a meaningful application. Anyway, Kubernetes is the platform of choice when it comes to running these cloud-native apps. One of the main reasons is it provides everything that you need to do the stuff we just mentioned, like scaling and canaries and the likes. Now, drilling a bit deeper, a Kubernetes cluster is made up of a bunch of Linux nodes, VMs or cloud instances, yeah? But some of them form the control plane and others the worker nodes. The control plane's the brains of the cluster where all the magic happens. Workers, I think the name speaks for itself, this is where your apps run. So you build a cluster, or maybe you don't, maybe you let your cloud platform do that. Either way though, there is a control plane. You want to make this HA, so 3, 5 or 7 nodes maybe. Again, if you're using a hosted platform like GKE or AKS, that's all taken care of. But that control plane is pretty much the API server, the scheduler, a bunch of controllers, and a persistent store. For now, the store's etcd, and it's the only stateful bit of the entire control plane. And if you're looking to run Kubernetes in a real-world production environment, and you're building your own cluster, you'll probably want to deploy a separate etcd cluster with its own HA. That way, the rest of the control plane becomes stateless, and upgrades and the likes are going to be way easier. But as well, you'll get better performance and separation of concerns. Now, to really help me get this point across, a bit of a pro tip, okay? If you're planning on Kubernetes for business critical, line of business production stuff, yeah? And you're baking it yourself, and it's going to be a big one, a big cluster, yeah? etcd. Yeah. It's probably going to be your biggest issue. And that's not really a pop at etcd itself. I just mean distributed databases in general. They're just hard. And when things scale, they start to creak. So if you're planning a big do-it-yourself production cluster, don't be tight with etcd and do a bunch of scale testing. Anyway, the API server is the gateway into the cluster. And we'll be talking about the API itself in a second, but the API server, well, obviously it implements the API, but it's like the grand central station of the control plane. So all requests to create, update, delete, and even list things on the cluster all go through the API server. So you as an admin or whatever, you're talking to the API server when you're deploying and managing your apps. But also, all the nodes and the bits of the control plane are talking to it as well. In fact, the vast majority of traffic on all Kubernetes clusters is system components that are talking to the API server. Well, with it being so central to everything, there's a ton of security around it, which we'll get into later in the course. But you've got your cluster, and you post requests to the API server to deploy and manage apps. The scheduler and the controllers take care of the mechanics of making those requests happen, and your apps actually run on the worker nodes. And then I guess underpinning all of this is this rich set of primitives that make Kubernetes the best platform of choice for cloud-native apps. So real quick, you write your code in a cloud-native way, lots of small specialized microservices, yeah? These all talk to each other over their own APIs, You package them up in a way that'll run on Kubernetes, and you feed them to the API server, and Kubernetes takes care of running them. Alright, let's have a look at the API itself.